this is the ice machine. And you can take these guys from here. And yeah, it's good to put your reagents on ice. So I'm putting probe, primers, master mix, and we have our DNA here. What else? So the recipe for Gull calls for the Quantitech master mix, forward, reverse, primer, probe, and water. So we don't need to worry about BSA. So we have everything in the way of reagents. We have our DNA for our samples. The last thing that we are concerned with is our standard, which is our positive control that we do on the plate. So basically we have either plasmid standards or genomic DNA for all of the assays. For Gull, it's a plasmid, and a lot of them have starting concentrations usually on the order of 10 to the 7 nanograms per microliter, or no, copies per microliter. I'm not quite sure of those units, but they're all written on the tubes where the plasmids are, and they're all, again, in minus 20 freezer here. So, down here on the bottom shelf is most of the standards. I believe that it's, this doesn't really mean anything, but this box has a lot of different standards in it. So red is Gull, it's written at 1 times 10 to the 7th, and that's a perfectly good concentrated stock that we'll use.
Can you show the label of that box a little longer? Okay, great. I believe that stands for orange, standard 1, right?
Yeah.
Oh, STD1. Okay.
I don't, but Gull 2-TACman is not on that plasmid.
Oh, okay, good to know. Yep.
Okay. Alright, so we know that we have 11 samples. We know that we have a standard, and we usually run a serial dilution of the standard on a plate. So we run usually 10 to the 5th, 10 to the 4th, 10 to the 3, 10 to the 2, and 10 to the 1. So 5 dilutions of the standard, 11 samples, so 5 plus 11 is 16, and then we'll do 1 negative control, which will be no template, just water, and so that's 17 samples on the plate altogether. We'll run them each in triplicate, so 17 times 3 is 51 reactions. So we're going to do 51 reactions on this plate today, and you should always add a safety factor when it comes to calculating your recipe, because remember that spreadsheet has the volumes per 1 reaction. You have to input how many you're going to use. So my safety factor for today, instead of 51, I'm going to put in 55. So come back to the spreadsheet. And here's where Gull is again. And here where it says 100, actually, that's from a previous run. I'm going to put in 55. And you can see that that numbers changed here. So it's telling me that I need 687.5 microliters of the master mix, 123 3/4 of each primer at the 10 micromolar concentration, 41 1/4 microliters of the probe at 10 to the 10 micromolar concentration, and 288 3/4 microliters of water. So usually by the time that you've figured this all out and taken out your stuff, that the hood should be decontaminated. I'm going to check the time. I have 8 minutes to go. So something that you can do to pre-think is actually to set up your, figure out your plate setup. So that's something that I usually just write in my lab notebook. So today I'm going to do this is what the plate setup is like. It goes from 1 to 12 at the top, A to H at the bottom. This is how I like to do my plates. You can do whatever feels comfortable for you, but just to show you my example, 10 to the 5th standard is what I do first, and then I make my way down. I'm going to put my no template control as far away from my standards as possible, so I'm going to leave this blank. And then I'm going to start with...
And just to be clear, so that means triplicates of 10 to the 5th, triplicates of 10 to the 4th. So 3 wells. Wells 1, 2, 3.
That's why, yeah. And I just did that naturally because I'm doing it. I broke it up into 3s because we're always working in triplicate. I need to refer to the samples here, but basically I'll just do...
While you fill that out, I'm going to stop it. Go.
So basically, we have this standard curve here, the no template control here, all of the 10 environmental samples here, and then I've left 2 rows empty between the samples themselves and the extraction blank because that's also a form of a negative control that we just want to avoid any possible cross-contamination between the wells on the plate. So the best way to do that is to try to make as much space between your concentrated DNA and your negative controls as possible. So this is what our plate's going to look like. That guy is still decontaminating. One thing to make sure is that you never bring your reagents or your DNA close to the UV hood while the UV light lamp is still going, because any exposure will totally annihilate the DNA or the reagents in general. So just leave everything out here while you're waiting for the UV light to finish contaminating. Once that's done, you'll turn off the fans, turn off the lamp, and then you can bring your reagents into the PCR room. So sometimes you have a couple of minutes to just chill, and that's where we're at right now. Okay, so the UV decontamination has finished. The UV light has turned itself off because it's on a timer, but the fans are a manual turn off. So the only thing we're going to use when we use the PCR workstation for actually mixing all of our stuff is the light. So I'm going to turn the light on, but I'm also going to turn all of the fans off. So just everything off, and now just the white light is on. Now you want me to open this up?
Well, whenever you open these things after UVing, try not to breathe that particular blast of air that comes out. So
I'm opening up the hood, and I'm not breathing.
There you go.
As per Tim's instructions.
Yeah.
So we're going to let that breathe for a minute. But note that I still have not brought any of my reagents into the PCR workstation area because I want to make sure that all things UV are gone. At this point, I believe them to be. So I'm going to bring my stuff over. So I have my reagents, I have my standard in here, and I have my DNA samples. You can share. So I was just saying that I've touched a bunch of things in the process, and so it's really important that you just change your gloves as often as possible. So before I even begin anything qPCR wise, I'm just going to put on a brand new pair of gloves, and I will also change my gloves pretty often throughout the process. You just want to be as clean as possible. So, I just want to get my thing. I'll be right back. Okay, so the first thing that I like to do, and this is something that, the first thing that I'm going to do is make the dilution standards. So this is where Kate and Darcy will disagree, but I think this is how I've done qPCR, and I've had good results, so I'm going to stick with my natural way of doing things, but there's always room for permutations of the plan. So I'm going to take out a brand new clean rack here, and this is the standard. Again, it's at 10 to the 7th, so I want to make a serial dilution of 10 to the 5 down to 10 to the 1, and I'm going to basically take 5 microliters of this concentrated stock and put it into 45 microliters of water, and that will make 10 to the 6th, and then I'll do that in a serial dilution way to make it all the way down to 10^1. So the first thing I'm going to do, I'm going to vortex this guy. I'm going to spin him down really quick. And then we have these tubes in here, and I need...
Can you show the label of the tubes?
There is no label on the tubes.
Oh, okay.
But there is a label. There are tubes that are labeled in the tip area, but they're just the 1.7 microliter pre-lubricated, low-bind CoStar microcentrifuge tubes. I need 6 of them, so I'm going to do this to get them out. I don't want to ever put my hand inside of the bag. So 1, 2, 3, 4, 5, 6, 7. Sounds good. I might need that one later anyway, so I'll just keep it out. Close this guy back up. And then close them. And then, do we have a marker? Yeah. I'm going to write the concentrations on the top so I know what I'm doing. So this will get 10 to the 6, 10 to the 5, 10 to the 4, 10 to the 3, 10 to the 2, and 10 to the 1. And I first put the water in. So we have molecular grade water, and there's actually some that are just for SIP projects only, and they say SIP only on them. So I'm going to use this guy to pipette out 45 microliters of water into each one of these. So we're using the 100 microliter pipette, which corresponds with the purple box VWR tubes. That color could change in the future, I don't know, but for now, the purple box. And this guy, I'm going to move him to...
Just real quick explain what kind of tips you're using.
You mean VWR? Or
they're
like...
VWR, but they're definitely filter.
Oh yeah, they're filter, barrier, low binding,
okay.
Sterilized tips.
Great.
And coming to you soon will be a video from Darcy about how to pipette and tips and everything you need to know tip-wise.
Okay, great.
So, for SIP projects only, we've only ever stuck with these VWR barrier tips, and we have a bunch of them in the lab, and those should be the only ones that we use. There are other ones in the lab that are around on the benches, but we only use these guys. So 45 microliters on the pipette. I'm just going to pipette it out. I'm going to do like just a quick rinse with the water beforehand, rinse my pipette tip with it.
Pre-wetting increases the accuracy of the pipetting. Or what she called rinsing. Same thing.
I'm releasing all the way, obviously, because I want the whole volume. Discard this guy back here. Close this up. I always assume that there is droplets on the side, and I want volume to be as precise as possible, so I will spin all of these guys down so that literally all the water is at the bottom of the tube. While that's spinning, I'm changing my gloves. We also need a garbage pail up in here.
Okay. We're at the